Welcome to the project demonstration of protecting distribution system employed with relay on PV side using Q axis components. So as you know that when we are distributing the power supply from the grid to the distribution section, there we need to consider the two axes. One is Q axis and another is a D axis. So the D axis is known as the quadrature. Sorry, D axis is going to be the direct axis, is axis which flux is produced by the field. So when the field winding was there, rotation, then the flux will be generated. That will be measured by the D axis. That is called the D axis one. And coming to the Q axis, as a quadrature axis, is a which torque was produced. Flux was produced in the direct axis and torque was produced by this in direction of Q axis. So when we are distributing that, so we need to by considering the Q axis component values, if the torque was increased by the threshold value, then we need to isolate the power supply, the distribution, so that we can protect the transmission lines and the transmitter section, so that unnecessary power won't be lost by this Q axis components. So here we are going to make the manual creation for the torques. That will be done with the help of this potentiometer, and continuously the system will measure the input from this inverter section, the Q axis component, whether the harmonics was generated normally or heavily generated. So based on the reference of these two inputs, our microcontroller will take a decision to isolate the power supply at the output of the distribution section with the help of this electromagnetic relay. So here the power flow is, we are using 24 volts 2 amp battery pack. So this battery pack consists of totally 12 4 volt 1 amp batteries. In that 6 4 volt 1 amp batteries are in series. So 6 into 4 will get 24 volts 1 amp, and here also 6 into 4 24 volts 1 amp. These two are in parallel, so we will get 24 volts 2 amp. So that is the inputs to the or inverting circuits. And also it which is rechargeable battery, as our project is based on the PV cells. So in order to recharge the battery, we need to connect the solar panel at this charging slots. So there we can see the charging slots on this one, T or S. So when we are demonstrating the project, so our project is PV cell based, that's why we need to connect the solar panel over here. So during the night times, when the sunlight is not available, if you want to charge a battery, then connect the transformer at this T slots and on the power supply to this transformer 230 volts AC input. Right, so now the LED indication, the battery is charging. So battery will get full charge in a duration of 6 hours minimum, 8 hours maximum. Till that duration we should keep the battery under charging only, and once it fully charged, you can utilize that for the project demonstration. So the very first step before demonstration of this project, so the whole night you can keep the battery under full charge. No need to worry, the battery won't get overcharged, as this charging circuit will block the current flow when the battery is fully charged. So now final demonstration is just connect the solar panel at this slot. When we place this solar panel under the sunlight, same we can see the light indication on this one. And coming to this charging circuit, there we can see the 4 diodes. So the diodes will act as a AC to DC converter when we are providing the transformer input, and when we provide the DC inputs, these 4 diodes will act as a polarity corrector. Means if we connect this solar panel in reverse direction, means instead of plus to plus, minus to minus, if we connect that minus to plus and plus to minus, then that will be rectified to polarity correction. After this rectification, we will get the directly plus to plus, minus to minus. Means if we connect the solar panel in reverse direction also, then the circuit won't get damaged, as we are using this bridge rectifier circuit. So when we are providing the DC inputs, these 4 diodes will act as a polarity corrector. When we provide the AC inputs, these 4 diodes will act as a bridge rectifier to convert the AC to DC. And after that, it's given as input to the battery through these diodes, which will act as a unidirectional current flow. Whenever the battery is fully charged, those diodes will block the current flow from the battery to the reverse of the solar panel or the transformer. So once the battery is fully charged, then that was the input to the inverter. So here we are using the inverter by using the CD4047 IC, which will act as a dual timer. So it will provide the 2 signals in unstable mode. So the unstable signal is input to the gate of these 2 MOSFETs, IRF Z44 MOSFETs we are using. So means the CD4047 will generate the 50 Hz of pulses. That pulses is alternately given as input to these gates of these MOSFETs. So from the MOSFETs we are going to get the 24 volts AC from this 12 volts battery DC to 24 volts battery DC to 24 volts AC 2 amps current, and that will be step up to the 230 volts with the help of this step up transformer, and that was input to this grid section. So in the project the grid was presented with this AC motor, and as the field and the torque will be varies for the AC induction motor only. We can use the AC bulb also, but that is going to be the constant load, and by here we are using AC motor, as we will get the variable harmonics generation and variable current, and that will be given us to this electromagnetic relay. So when we on the gates, our microcontroller start reading input signals from this MOSFET gates. So whenever the harmonic generated heavily, then the control will get the fluctuation in the signals of the square wave, and also it will check the references. If it is 0, then it won't do any operation, as we set the limit for the 0 only. When we increasing that, it will checking the sensitivity levels, and then automatically when they cross the threshold value, then the relay will be get isolated, means it will off that, and it will block the current flow, it will isolate the power supply to the distribution section. So now let us see the demonstration. First of all, on the power supply to this microcontroller, so keep this in 0. Okay, and now on this, as you can see the motor rotating. Okay, so you can see that right now the speed is increased. The initial torque will be needed, and once it reaches some torque, then the speed also will be increased to maximum speed. So as we are using the motor of 1200 rpm motor with this of 100 watts of power, so when I'm increasing that, so it crosses some threshold value, right, then automatically power supply will be isolated to the distribution section. And when again it is normal, let's switch it on. So if it's not rotating directly, just you can do some inertia for the AC motor. Slowly it rotates. Once it reaches the sufficient torque, then it reaches the maximum speed. Right. Okay. So we should keep the battery under fully charged. Right.